Hello friends, welcome to the session on data structure. In this session, we will be discussing about certain operations on the linked list. Friends, as you know that linked list is basically a list of elements. Like array is a list of elements, linked list is also a list of elements. But the only difference between array and the linked list is that in array we require the continuous memory locations in order to store the elements. While in case of a linked list, every element has a pointer to the next element, and therefore it is possible that you can create the linked list in any part of the memory, and all the nodes are connected together in the form of the pointers. So friends, linked list is a very useful data structure, and many operations in real life or in computer programming can be implemented by using this data structure. Also, this data structure is useful in order to implement other data structures. So, other data structures like queue can also be implemented by using the linked list. So, in this session, we will understand how to perform certain operations such as insertion and deletion in the linked list. So, as we know that arrays are very useful data structures, and these data structures are implemented whenever we have been given a sufficient memory location, a successive sufficient memory location. But if the successive sufficient memory locations are not available, then in that case the implementation of the large arrays becomes difficult. Also, you will find that the insertion deletion operation on arrays are difficult, particularly when we want to delete or insert the element in between the two elements, or whenever we want to delete the element that is present anywhere in the array. And these problems can be avoided, or these problems can be resolved to some extent by making the use of the linked list. As shown in this diagram, one can easily observe that linked list is basically a collection of nodes where every node will hold some value, and it will also have a pointer, and this pointer will point to the next element. So, in this way the elements are connected to each other, and they can be represented in anywhere in the memory, and the last element will have a null pointer value. So, that indicates that this is the last element of the linked list. Now, as we know that whenever we have been given any data structure, then we can perform certain operations on the data structure. Say for example, whenever we want to visit each and every element of the linked list, then that is being called as a traversing operation. In our earlier session, already we have discussed how to write algorithm to perform the traversing operation. Now, it is possible that you can insert new element into the linked list, or you can delete the element from the linked list. So, whenever you want to perform the operations like insertion and deletion, there also you need to write appropriate algorithm to perform these operations. In this session, we will discuss how to write algorithm for insertion and how to write algorithm for deletion operation. The searching of the element is another operation that is being performed on the linked list, and in our earlier session we have already discussed how to search a key element in the given linked list. Now, let us understand how to write algorithm for performing the insertion operation in the linked list. Now, suppose we have been given some linked list, and now the task that is being given to us is that we want to insert some new element. As we know that element in the linked list is basically a node which will consist of a data value along with some pointer value, and now we want to insert such node into the linked list. And now there are different ways of insertion. Say for example, we can insert the element at the front of the linked list, we can insert an element before a given particular node, we can insert an element after a given particular node, we can insert an element at a specific position, and then we can insert a node at the end of the linked list. So, element can be inserted anywhere in the linked list. It can be inserted at the front, it can be inserted at the end, it can be inserted in between the two particular nodes, or before a particular node, or after a particular node. So, there are different ways of making insertion of the element into the linked list. Now, as far as this session is concerned, we will see how it is possible to write algorithm for the insertion of the element at the front. Now suppose we have been given a linked list and now we want to insert a new element or a new node at the front of the linked list. And for that what we will do is that we need to create a new node and we have to point its next reference to the current head of the linked list. And then what we will do is that we will update the head and we will make the head to point to this new node. And this is a very efficient operation because it will require adjusting only a few pointers. So insertion of the element at the beginning of the linked list is comparatively an easy operation, because here what we need to do is that we need to make certain adjustments in the pointers only. There are no further adjustments required, and therefore we can say that insertion of the new node at the beginning is the most efficient operation. So what can be the steps of the algorithm? So first of all, what we will do is that we will make the first node of the linked list linked to the new node. So before you are inserting, you need to create a new node. As we know that node will consist of two things, one data value and another is the pointer. So create that new node. And then what we will do, we know that every linked list has a head pointer. Now this head pointer you need to remove from the original first node to this new node, so that now the head pointer will point to this first node and the pointer value of this new node will point to the original first element of the linked list. So make the new node as the head of the linked list and then you will find that the element will get automatically added into the linked list. So these are the three steps that one need to perform in order to insert one new element into the linked list. Now let us understand how it is possible to delete an element from the linked list. Suppose we have been given a node and now we want to delete this node from the linked list, and there are different ways by which we can delete the element. The deletion can be done by removing the first node, or we can delete the element if it is in between or in the middle of the linked list, or we can delete the last element of the linked list. So like insertion, in deletion also you will find that either it is possible to delete the first element of the linked list, or you can delete the middle element of the linked list, or you can delete the last element of the linked list. Now let us understand the steps that we need to perform whenever we want to delete at the beginning of the linked list or the first element of the linked list. Now whenever we want to delete the first element of the linked list, then what we need to do is that we need to change the head pointer, and this head pointer will now point to the second element of the linked list instead of pointing to the first element of the linked list. So only simple way of deletion is that you make the changes in the head pointer in such a way that it was earlier pointing to the first element of the linked list, now change it and make it point to the second element of the linked list. If you do this, then you will find that the first element will get deleted from the linked list. Of course, you have to make sure that the list is not empty, because if the list itself is not containing anything, then you will find that there is no question of deletion. So whenever you are performing any deletion operation, you have to make sure that the elements are present in the linked list. If there are no elements present in the linked list, then the deletion is not possible. Now suppose you want to delete an element at the specific position which is being present in the linked list. Suppose we have been given a linked list, and if the position is at number 1, means if it is at the beginning, then you will find that you can make the simply change in the head pointer and you will point to the next node and instead of the current node, and therefore the deletion will take place. For other positions, what you need to do is that you need to traverse the list and you need to see the node which is just before the specific position. So if I want to delete a particular element that is being present in the given list, then what I need to do, I need to make the visit to each and every node, and this operation is being called as a traversing operation. So we need to traverse the list and then we will see which node is to be deleted, and just we will place the position just before the specific position. And if the target node exists, then we will adjust the next of this previous node to point to the next of the next node, and therefore you will find that the target node will be deleted. So you have to adjust your position appropriately before the target node, and now change the pointer value of this node to point to the next element of the target node. And if you can do this, then you will find that the target node will get deleted from the linked list. If you want to delete the element that is being present at the end of the linked list, then you will find that what you need to do is that you have to traverse the list and you have to go to the second last node that is being present in the linked list. And then what you have to do is that you need to change the pointer value of this node to null, so that the last node will get deleted from the linked list. So whenever you want to delete the last node of the linked list, you have to do these steps. Just place your position before the last node, that is the second last node we call it, and then make the position in such a way that the pointer will point to the null. So whenever the pointer is pointing to the null, it means that this becomes now the last node. The second last node now becomes the last node, and therefore the last node gets deleted from the linked list. So thank you friends for viewing the session. Hopefully you have understood how to insert the element into the linked list and how to delete the element in the given linked list that is being available at the different positions. Thank you all for viewing the session.